because it's an add-in that you have to download. The other thing which is important, do's and don'ts. There are some things which should be done in a specific way and will be a bit untypical to your normal workflow. And the last most important thing is to design faster in multi-engineering environment, because this method is actually making the things much, much faster. So, yeah, here are the takeaways again. And a little bit about myself. As Stephanie already mentioned, I'm Danute Petrova-Nikolova, also known as Dani. I'm SOLIDWORKS power user, certified expert, the first actually champion of the year. And I'm designing probes and equipment for the measurement industry since 2013. We started with a simple design collaboration, a Seagull, went through SOLIDWORKS PCB, which is not available anymore. And the last thing now I'm using is Altium CoDesigner. I'm working with companies which are in the space industry, automotive for electrical vehicles, and energy storage industries at the moment. I'm also a content creator and have a channel, the workshop, in which I'm trying to, not only to show how to use SOLIDWORKS, but also to show it in a different light and to inspire people. And here are some links which I can share a bit later in the chat if you want to connect with me. Oops, sorry. So now let's go to, I will stop sharing this. And we're going to SOLIDWORKS. Okay, so usually when you're working with PCBs in your models, you receive a step file from somewhere. Oh, this is a bit uncomfortable here. And you import them, and usually they're very heavy. This I use very heavy when I mean it's hard to operate with them. When a board is imported with CoDesigner, I don't know for what reason, no matter that everything is still a lot of parts, it's behaving a bit different. So it's a bit easier to work with. It has a different behavior than normal step imported. When you have that, you will have a screen here in which you can either pull a board from the server and see the changes which the engineers, electronic engineers have done, or push your changes to this board. And what I mean by your changes, you can change the shape of the board, you can add holes, you can add enclosure, you can also add some notes. You have here additional menu, which is showing the different things that you can place inside this. But how all of this is starting? To see all the boards that are on the server, you should be either without any open part or go in a part which is not a board already. Then when you hit the pull button, you will see all that you have on the Altium server as designs, but you're not able to take everything. So if you click on any design, you will see who made the last change. In this case, it was me. But this board, for example, you will see that you don't have any pull. This means that the electronic engineer didn't push this board to the server, so you cannot take it. In this case, you have to call him and say, hey, please push the board. So I will not make the pull at the moment because it's a bit slow process. You saw already one of the boards. And this is another one, which is a flex one. And when you have a flex board, you can see it both in its flex state or folded state and also unfolded state. What I find as a really nice feature in this case is that you can also control the folding points of the board. When you enter in the flex part, Okay, it's a bit slower when I'm sharing the screen. You can see that it's actually based on sheet metal commands. So you can change all of the bands and also update this information to the electronic engineering if it's not fitting with your design. So these are the methods in which you work with the ready board, but in many cases, you have to define the shape. And that's the base difference when you really start working with CoDesigner, that you should teach a little bit at the beginning, the electronic engineers, that you're the person who is doing the board outline. Because the way they create it, they have to define every point, especially when it's a shape like this. And in SOLIDWORKS, this is like less than 5 minutes work. For them, it's few hours. So either you create the project first and shape the board for them, or they make you a simple board, you pull it, shape it, and push it back. For 5 minutes, you can have a perfectly shaped board, and everybody are extremely happy. Now, I will show you how exactly you create a new project. So you're creating the board. You click on the button Create, then hit here on New Project. And this one in your owner will be New York City. And then you hit OK. Now it will ask you where to save this new project. And it will start creating everything you need for that. And now, as you can see, you have a baseboard here. It's still adding some features, which you can shape in any way you wish. When you're reshaping a board and you're adding an enclosure, you should insert this in a new assembly. So you never work directly in the assembly that you receive from Altium. Because if you work directly in the assembly that you receive from Altium, you cannot define the enclosure. Now I place it in a different assembly. I will first save it. It's in the same folder. And now I will insert my enclosure, which is this demo housing. And the only thing I have to do is just to make it coincident to the board. Then edit the sketch, delete everything that I have here, catch this face, make an offset. Okay, I'm thinking, okay, so and then you exit the sketch. And the board is exactly in the shape that you need, or actually your other engineering department needs. At this point, you have to go to Altium CoDesigner and hit Recognize PCB, because we have already created a new assembly and we have placed the PCB assembly inside. This is happening fast. At this point, I can push the project here. I can leave a comment for the engineer, what I have done. They're seeing every single change. They may decide not to accept some of the changes, but you can describe just for better workflow what you have done. So later you can see from the different pushes to the server, the one that you're looking for. In this case, it's a sample, so I put no description. And that's it. The board is ready on our side, and the board is ready also on the other side. Now I will go to the projects here. And when I refresh it, you see I have a new project, which is New York City, and this is the board I have just created in SOLIDWORKS and the project itself. So at this point, it's not visible because it's still not pulled from the engineering. Once they pull it in Altium Designer and save it, it will be visible everywhere. Another thing which is important when you are shaping boards for Altium CoDesigner is that you cannot have additional lines. You cannot put construction lines inside, because if you do so, it will say you have more contours inside and you cannot upload this to the server. So it will not accept changes. Now, when I'm here, I want to say that this is actually the enclosure. So I hit the enclosure button, and it says there are no selected parts. So I think I have selected this one, but it seems I haven't. And now you can see that there is a definition for PCB enclosure, which is added to the design itself. The same way, if you want to add holes or cutouts, you can do it directly from the assembly. But you should go and edit the board part and choose the hole. Select a plane, and it will be good if I put some transparency to the board at this point, or to the enclosure itself. Ah, okay, now. Putting the holes is at first a bit strange, because you will be able to place one hole. But then you will see that this is the whole wizard, and go to edit feature. And okay, it's not exactly as I wanted it. It should be sketch. Maybe I should edit it from the from the sketch itself. Yeah, this is also something which I don't use often, and the reason I'm not too used to that. So you have to go into the sketch and then position everything. Otherwise, it's showing the Altium features, which are just the size of the hole. But once you're in the sketch, you can place different holes on different places and finish the operation. And of course, later you can adjust also the position more precisely, or the size. So the other thing that you have is the cutout, which maybe you will use just if you have a cutout inside the board. For the edges, you will make it part of the contour. But if you need a cutout inside, then you have to use the cutout area. In addition, you have text note that you can place somewhere, and the fold and fold I show you, it's just for flex boards. So more or less, these are the most basic things for this, and just wanted to show you also that you can move components. Okay, this one is fixed. Okay, that's actually also something important. If the component is staying fixed in your menu, this means that the electronic engineer has locked this component and you're not able to move it. Only the ones which are not fixed, you're able to move around. And when you push again to the server, then the electronic engineer will pull it back. So we'll see it updated in their design. Why is this important? Well, mostly connectors. They cannot place the connectors correctly from the first time ever. And well, more or less, that's all for the basics of Altium CoDesigner and SolidWorks. Now this PCB here is already opened. And my CoDesigner menu is missing. Okay, so go to that. I'm not an Altium user, so you have to excuse me for that. So CoDesigner, yeah, I won't be able to show that. I place it on the side, but it disappeared. Now I'm open for any questions that you have. And okay, Josh, that's not a serious question. I'm happily married for a very long time, and I have 18-year-old son.
Oh, wow. So I don't see any other questions, but I think we can save the questions till last. For now, the time being, we can shift to Rafael Testai's presentation. So Rafael, do you mind taking over?
Yeah, here we go. One second.
Thank you.
So can we see, can everyone hear me well?
Yep, we can hear you.
Good. Okay. Can we see like how many people on the stream, or is that accessible? Let's see.
Yeah, we have 12 participants and a few questions.
Okay. All right. Can everyone see my screen? Or no?
Yeah, we can see your screen.
Try that again. We're trying to try the other one. 1 second. All right, everyone. Welcome. My name is Rafael Testai, and today I'm going to teach you RCM. Now, before we even get started with the whole presentation, I'm going to do a quick flip through of all the slides so you can see what's coming ahead. Because that's like very much like reading a book. When you read a book, the first thing you want to do is kind of like flick through all the pages, look at the pictures, look at the titles, so it preps your mind as to what's to come. So your brain can absorb the information and remove fear from the educational experience. So let's just quickly flip through the slides. Everyone can see like the purple slide now, right? Like the little purple button. Just making sure. Okay, I see nodding over there. All right, so I'm going to show you where to find this class, where you can find me. I'm going to make an analogy, another analogy. And then I make a little joke, an analogy. Analogy is important to grasp the information. Now we're going to start diving into why should we use the RCM method for CAD, what it is, how does it work, what is design intent, orthogonal views, a couple of examples, then the group. So we're going to dive into the details halfway through the presentation. Really dive into the details further. Some more examples, a little more advanced with multi-body practices, how to edit the RCM model, some pro tips, and RCM Lite. So if you saw a lot of text in these slides, and maybe you may be a little bit concerned how much information there is to absorb, even if you absorb just 10% of the information today, you're still going to be a better mechanical design engineer. So no worries if it's too much information. It's the concepts that we can really grasp from this presentation. This is where you can take the class, learnrcm.com. I'm going to tell you about an initiative I'm working on and how you can find me. All right, so let's take it from the top. All right, so my name is Rafael Testai, and I'm a SOLIDWORKS influencer and content creator. I really love teaching people how to use SOLIDWORKS, and it's just one of my passions. I love to invent. That's why I chose this profession. We're going to cover what it is, how does it work, and why should we use it, RCM. Today is simply a glimpse of the full class that you can take on Udemy for just $10, and over 2,000 students have already taken it. This is where you can find me and how you can spell my name, Rafael Testai. So if you want to, you can take a screenshot right here, so you can always stay in touch. The next thing here. So some CAD models, it's like a stack of Jenga blocks. If you remove a sketch or you change a feature down the feature tree, it can easily fall and blow up on you. And that's where RCM comes in. Because we've all been there, we've all experienced, there's a little bit of lag. That's why I'm like in between the slides, I wait a little bit. We all experience this. A feature tree just totally blown up on us. It's the worst feeling. You gotta become a detective, find out where it came from. So RCM can aid you with that. This is a little joke. One does not simply add fillets in SOLIDWORKS. So if there's one take-home point that you can take from this presentation, is that fillets and chamfers should be used at the very end of your feature tree. Because they create artificial edges. I would love to say, like, by show of hands, how many people knew this, but it doesn't work. Well, maybe with the presenters, by show of hands, like, how many knew this? Okay, I see a little clap. Okay, right on. Interactive. Love it. All right, so this is another analogy. I'm going to summarize it. Truck Audio 1 was going to be complete. No, I see more claps over there. Thank you. Track Audio 1, it's just a bunch of noise. You just imagine like piano keys all over the place being pressed. And audio track number 2 is just in the very eloquent Mozart song. And here we make an analogy that if you model your CAD model using RCM, this technique that I'm going to show you today, it's more like a Mozart song. It's very eloquent and very well placed and relaxing. So why should we use RCM? Your models are less likely to break. There are standard rules that the whole team can understand and follow, which makes inheriting the models easier from each other, right? Your coworker goes on vacation, you got to pick up where he left off from. You got to learn the way that your coworker works. It just sets back the entire company. The company's wasting money. But what if everyone knew how to model the same way? They all follow the same procedure, and that's where RCM comes in. So in the long term, like anything else, there's a little bit of a learning curve, but once you and your coworkers learn how to model like this, you become a much more interactive team. What is RCM? As you can see, it's a defined set of rules and best practices for creating robust CAD models. What does robust mean? Robust is hard to break, durable, less likely to blow up. It makes your team more productive, you learn faster, and you reduce the chaos. It helps suffocate the chaos and promote order in the CAD models, and editing the models becomes easier, as I mentioned before. All right. So before I was introduced to RCM, like everybody else, I had my own way of doing CAD, and other engineers have their own way of designing. So like I explained before, like whenever you collaborate, it's just a mess. You have to learn the way that your coworker works, and it's very challenging. So let's see. Now let's dive into some of the group hierarchy. Let's shift our focus to the picture on the right, and let's look specifically at the feature tree. We have folders, right? Some of us use folders, some of us don't, but it's a good practice because you get to really organize. It's like your house. You get to really organize where things belong. You got the skeleton, core group, surface detail, so on and so forth. I'm going to go over those in detail later, what they mean. Now, gee, I would love to ask, what is design intent? Like put someone on the spot. If there was a classroom, that's what I would do. So design intent is the sketches, the planes, the axes, essentially what you're seeing right now in the middle. And it helps you think through the design before you rush into the solid modeling. So in RCM, you come up with the skeleton. It makes sense, right? What would we call it the skeleton? Let me go back to the slide before. Remember? Skeleton right here. What would we call it that? Well, that's where the design intent lives because it looks like a skeleton. And it forces you to see three-dimensionally and develop that skill that's actually so useful for a CAD modeler. Like if anyone knows CAD, they see this floating in the air, you can kind of maybe get an idea of maybe what's to come. Like if you look at it on the right, you look at it on the left, you can see how all the features were made. So anyone that's a beginner, don't be intimidated by this. If you get to the point that you can see the relationship, you're making progress. So RCM helps exercise that muscle to become a better CAD modeler, to see things. A key step to get to this point is understanding. This is so cool that I get to teach you this because a mentor taught me this called Aaron Munker that works at Team Pipeline. I have to give him a shout out. Teampipeline.us, which is the company that helped design and invested in creating this class that you can take on Udemy. He invested in me and taught me this. And when I wasn't picking it up, I was like, why is this not making sense? And this is why I think I'm the perfect person to teach this, because I learned this not too long ago, maybe 2 years ago. It was because orthogonal views. Some of us familiar with engineering, orthogonal views. Once you can visualize how to do orthogonal views, that's going to help you a lot with RCM and CAD modeling. Something so simple, right? All right, so now we're going to talk about multi-body part modeling in another class that's a little more complex. So we're going to stay to single part modeling for RCM purposes. Excuse the lag. This is the RCM cheat sheet. So where do all the features belong, essentially? Remember we talked about the skeleton group at the top of the feature tree? Well, that's where the design intent lives. And I explain what design intent is. So the solid features, no duplicate dimensions. You have the links between the features allowed. So everything that you're dimensioning, dots in the space, planes, that's where all the bulk, the meat, it's of in your RCM model. And there are no rounds or fillets allowed in profiles. Then we have the core group, which is where you start creating your extrusions, your solid bodies. Before, there were some planes and sketches like floating in the air. Now you're creating the extrusion and the bodies start showing up in the model. More groups. And more groups. Some examples that I go over in the full class on Udemy. some of the best practices for multi-body parts. So as I mentioned before, the skeleton group contains the reference entities to all the components. Gee, I wish I could go into like a thorough, super detailed example, but if I open up my SOLIDWORKS, it's going to go super slow. But in the Udemy class, I show you how to do that. You want to keep your multi-body parts about 8 to 10 components. So we had a joke at this company that I worked at Pipeline in the bottom right corner, that there was a coworker, I'm not going to say their name, but we would joke, we would say like, this guy, he'll build a car inside a multi-body part. So it's like, it's just too much. Like you don't want to have a car. Maybe you want to have a door, right? So that's how you want to have multiple multi-body parts, and then you bring them together in a top level assembly. I think I should do a class on that one day, like a whiteboard class on like with arrows pointing and how, because all CAD, this is like off script right now what I'm saying. All CAD modelers, we have this in our mind of how all the files have associativity, but I don't think no one ever really explains that. We kind of just know. Maybe I should be the one. Maybe it exists already. If it exists, let me know. Shoot me a message. But I think I'm going to do a whiteboard, literally me in front of a whiteboard, showing how a file associativity works in SOLIDWORKS in the future. Pro tips. So don't try to be, we're coming to the end of the presentation, the last 20% here. Don't try to be linear. You're going to have to bounce up and down in the feature tree. You know, when you grab that, the line on the feature tree that it's like, who knows the name? Because now I'm curious. I forgot the name of it. It's like well, you know what it means, like the history. You can go up and down. And so you create a sketch, you go down, you create the solid for it. Come back up, you create another sketch, you go down, you convert the entities and create another solid. It's bouncing. That's what we'll call it. This is a really important rule that I want everyone to take home. That I know that you've seen slides that are very dense with what should go in each group. But at the end of the day, you are the master of RCM, and it's not the other way around. So if you want to break some of the rules, feel free. It reminds me of that YouTube video by Schwarzenegger. I don't know if how many of you have seen it, like these inspirational videos. It's like, break the rules. You got to break the rules. I wonder how many of you have seen that. But I watch inspirational videos every now and then. And like I said before, even if you remember just 10% of what we talked about today, that still makes you a better mechanical designer. Even if you remember, maybe you go back to work the other day and you tell your colleagues, hey guys, there's actually a way that we can all model the same way so we don't have to learn each other's style. And that's called RCM. Even if that's the only thing you remember, that's still a win. It made you a better mechanical design engineer, makes you more aware of how CAD could be more efficient. And I wanted to introduce you to RCM Lite. If you just remember some of these concepts, like using a skeleton group, and then you do the extrusions, and you put all your design intent at the top, then that already makes you a lot better. Where can you take the full class? Right in the middle, learnrcm.com. All right, that concludes the first portion of my presentation. And I want to talk to you about a project that's the next thing that I'm going to be doing that I'm super excited about. And this is industrial automation. A new company that got started very recently. We're going to launch pretty soon. What is industrial automation? Well, there's this new wave, as we all know, of artificial intelligence coming in. So many people are worried, right? They're taking our jobs. I'm imagining like people holding big signs. They're taking our jobs. Well, what can you do as a CAD modeler to protect your job from this whole AI revolution? You may want to learn industrial automation. What is industrial automation? There's a couple of McDonald's in the United States that have already launched that they're completely automated. You drive through the drive-thru, there are no employees working there. There's all machines picking your order, flipping your burger. Who made that? People like us, people that do CAD, people that code. That's industrial automation. So if you learn those skills, which is the academy that I'm going to be jumping into and teaching people, that's the way to like have good job security, make good money. You know you're going to be employed because everyone's going to be jumping on this wave. So if that's even remotely interesting to you, you're going to be surprised. This is actually free for the first 50 people. We're just starting out. Add me on LinkedIn. Send me a message. Screenshot this right now. Send me a message like, Rafael, saw your presentation. Here's my email. Give me your email address and I'll put you, the first 50 people that email me, I'm going to put them and they're going to be early adopters for this academy that's going to teach you industrial automation. My name is Rafael Testai. Thank you for watching.
Awesome. Thank you, Rafael. So just opening up if there is any questions on that, open up the stage for anyone who wants to ask Rafael something.
I see someone, Franco, a rollback bar. Franco, thank you. I gotta add you on LinkedIn. I'm gonna copy your name and let's find you. Let me see. Franco Rotoli. Rotoli, is that Italian? Because I'm Italian
thank you,
too.
Chris Acher. Thank you for your comments as well. Okay, so this is gonna come in as a little bit of a surprise, but we have a question that we want to pose to everyone, and whoever types in the correct answer in the chat will get a $25 gift card from SOLIDWORKS. So this is a perk that SOLIDWORKS User Group Network does provide to webinars and meetings. So we're opening it up. And I believe you had one question that you wanted to pose.
Yeah, I have one question. And the question is, which is the command that you use to take a PCB in SOLIDWORKS from the Altium server? What's the name of the command? I mentioned it about 50 times in this presentation. Or maybe I should type it as a question.
I think that's fine.
Okay.
All right, I don't think anyone's getting that one. Rafael, do you have a question that you can ask?
Let's see. Yeah, I can ask. If you want to have access to the free industrial automation classes that we're going to be launching here pretty soon, what do you need to do? Who do you need to send your email to? Okay, I can't get any more easier than that. What's that person's name? Wink, wink, wink.
Perfect. Okay, Gary, I'm going to ask you to just send me your email so that I can add you to send you the $25 gift card. So thank you so much for these presentations. It's been super informative to learn how to collaborate with Altium and your new initiatives, Rafael, for the automation class. So I'm going to just start sharing my screen because I do have one little thing that I want to share.
I'm going to stop sharing.
Yeah.
There you go.
So we've concluded the presentation. And first of all, just to wrap up, I want to thank you both so much for your technical presentations. It's been very, very insightful. I have 2 certificates of participation that I'm going to send you over. I've kind of bundled them up together in this slide just to say, as a show of appreciation of you participating in these. So thank you so much for your time, your insights, and your dynamic presentations. It's been fantastic to learn from you. The presentation is going to be broadcasted, or it's going to be presented in YouTube. We're going to leave it for everyone to share. And I'm going to add the information that you've both provided as part of the description if you want to have more access to the LinkedIn information and the user group terms that we've gone through. So thank you so much. As I said, here's my few minutes of call to action for the group. This is the first webinar that we have, but we're going to be hosting other events throughout the year. You can get involved going to the Meetup website for SOLIDWORKS User Group Network, or you can follow us through our Twitter handler at NYC SWUG. That is NYC SWUG. And then I am also looking for presenters constantly. So if you're interested in presenting, have a topic about SOLIDWORKS or industry applications that you're interested in showing, please reach out to me. And you can reach me out to nyc@solidworksusergroup@gmail.com with a header, presenter, intro, and then your name with a small blurb on your preferred topic to talk about. So that said, thank you so much for your time, and I'm gonna conclude this conversation. Thank you.
Muchas
Thank
gracias.
you.